Good afternoon, everybody, or good morning if you happen to be on the West Coast or elsewhere in the world. My name is Jason Hodgert with PCI Geomatics, and it is my pleasure to welcome you to the latest in our webinar series, the Geomatica Roadshow we've been calling it. This specific webinar is about SAR image analysis with the latest release of our Geomatica software, Geomatica 2014. And what we're going to see over the next hour is Kevin Jones is going to be demonstrating data processing techniques in Geomatica, including ingesting, calibrating, and displaying a synthetic aperture radar data. This webinar is going to show how to apply radiometric enhancements, processing detected data, performing unsupervised coherent and incoherent decomposition, and coherent change detection with polarimetric data, as well as some land use classification examples. It's really interesting if those of you are not necessarily familiar with SAR data and what it can do as opposed to optical data, which is also something that we process with our software here at PCI. It's definitely very interesting, the applications you can do, and we think that everybody will enjoy it. Before I do pass it on, though, I just want to go over some of the logistics. If you're not familiar with a webinar using this interface, know that all of your lines are muted during the course of the presentation, so you can talk amongst yourselves or work in the background and know that you won't be disturbing anything. We are going to have a dedicated question and answer session following the live presentation, but if you have a question at any time, feel free to enter it into the questions box, and we'll queue it up to save to the end during the question and answer session. And of course, one of the most popular questions we get is, are we recording this? Yes, I am absolutely recording this right now, and we will be sending out the slides and a recording following the presentation. Presenting today, we have myself. I'm on the left. I work in the marketing department. I'm just outside of Ottawa, Canada, in Gatineau, Quebec, actually. And I'll be keeping things moving along and introducing a couple of polls to gauge your interest and see how we're doing. And then in between me doing that, Kevin Jones, the Director of Marketing, my boss, also here in Gatineau, Canada. Kevin has 20 years experience in the remote sensing industry, has worked for a number of organizations, has been at PCI for 6 or 7 years now, and has a real wealth of knowledge in SAR data due to his background. And Kevin's put together a great use case scenario and a and a live demonstration. So I will pass it on to Kevin shortly, but first I do want to get to this first of these 3 polls that I was talking about, and these polls really help us put together better demonstrations and actually help make our software more usable for users like you. So very quickly, just want to know, how familiar is the audience out there with SAR data? Perhaps you regularly use SAR data and are looking at some new tools. Perhaps you know about SAR but are looking at different use cases, what kind of things you can do with it. Or perhaps you've heard very little about SAR, are used to using optical data, and are looking for the benefit analysis as to why SAR would be a useful data set for people to use. Excellent. Thank you for taking part in that poll. Quickly share the results. Most people there, about 40%, have some experience and are looking for different use cases, and then about 30% each are regularly using SAR or mainly using optical data. So thank you for taking part in that poll. I will be back a couple of other times with some more questions to ask of you, and I'll be hosting the question and answer session also. But now I'd like to pass it on to Kevin Jones to talk about all about SAR and what you can do with it in Geomatica. Go ahead, Kevin.
Thanks, Jason, and welcome everyone to our webinar. It's great to be here. Thank you for making the time to learn about synthetic aperture radar image analysis using our software. And just to quickly go through an outline, I just want to quickly mention that this webinar is part of a series of webinars that we've been hosting for the last number of weeks. And I just want to bring to your attention some of the most recent ones that we've done in case you are interested to go back and look at a recording. We will then look quickly at the past, current, and future capabilities for SAR here at PCI. Then I want to spend a little bit of time explaining what the advantage of working with the Geomatica system is for SAR imagery. I'll go into a live demonstration, and then I'll come back and summarize with some of the new items that are available in Geomatica 2014. So Jason will be coming in every now and then with a poll. There's two other polls that we'd like to do today. So let's get right into it here. So we've had a number of webinars, as I mentioned. The focus of these webinars has been on the fact that imagery is more than a base map, and so we've put together these themed webinars that hopefully give you some knowledge and instructions for how to use the tools and what type of imagery to use for different application areas. Here what we see is a webinar we did in September on using stereo overlapping imagery to derive elevation information, in this case digital surface models, and looking at those changes in DSMs to calculate volumetric information. So if that's a topic that is of interest to you, I encourage you to visit our website and download the recording. We also have done some webinars with some data providers. In this case, we focused on the use of the Rapid Eye constellation, the multiple satellites that collect imagery over all over the world on a daily basis. And we focused on using Geomatica together with the Rapid Eye imagery to calculate vegetation indices for crop health assessment and crop management. We also recently did an interesting webinar together with Esri. Esri has a software tool called City Engine, which is actually came out of the entertainment industry and is now in part of Esri and is part of the geospatial realm. Together with Esri and also with a tool that we make available called 3D Feature Extract, we can create 3D cityscapes, one of which you see here. So in this webinar, we walk through how we can do that, the varying level of detail that can be derived through automated means and more user-driven means in terms of extracting features of interest. So if you're interested in that, please check it out. And most recently, a couple of weeks ago, we did a webinar together with our partner MDA, McDonald Detweiler, on the use of synthetic aperture radar for disaster response. Here we see an example of flooding. This is a classic example in Canada's western province of Manitoba, where there's quite a bit of flooding that occurs here, and the map that you're seeing up on the screen is something that was derived using Geomatica. We also looked at oil spill mapping and characterization of oil spills using polarimetric information. So I encourage you to look at this particular webinar. If you are obviously here, it's because you're interested in SAR, and so this other webinar that we did a few weeks ago is probably something that you would get benefit from. So a quick few words on PCI Geomatics and the development of SAR technology and SAR expertise over a number of years. I just want to mention that Canada has been an innovator with synthetic aperture radar for a number of decades now. Starting back in the 1980s, there was a requirement identified by the Canadian government to map the ice flows in Canada's north for navigation, for safety, and that really drove the requirement for a satellite to be used to collect that imagery in a much more quick and efficient manner. Previous to that, airborne radar imagery was collected, and that just became difficult to manage and so on. And so Canada has been really at the forefront of developing SAR capability, both in terms of the instrumentation and also the processing. And PCI has been there since the beginning. We developed some of the early software that was used to work with Convair data. So this was the initial simulated radar data that was used before the launch of RadarSat-1. And also we've played a key role in outreach and capacity building. We have participated in programs which some of you may know, GlobeSAR, which had the goal of providing training and providing sample imagery and software for people around the world in Latin America and Asia and in Africa, where really the building up of the knowledge base for handling radar imagery was the goal of that program. And we've also developed in partnership with the Canadian government through funding several tools, which you're going to be seeing here today. We have a specific suite of software capability within Geomatica that is meant to work with polarimetric information, polarimetric radar data. And those tools were partially funded through the Canadian Space Agency's programs. Just another word of mention that although I'll be showing RadarSat imagery here today, we are sensor agnostic, if you will. We support all of the different sensors to the extent that we can. And to that end, I think my next slide is on the types of sensors that we support. This may not be the most up to date. I know there are new missions that are just being launched, and data is becoming available now. For example, the Sentinel-1 mission, and so on. But these are probably the most commonly used data sets right now if you're doing any research on SAR, or if you're working with SAR operationally for agriculture or anything like that. RadarSat 1 and 2, TerraSAR X, Cosmos SkyMed, UAV SAR, PAL-SAR, ASAR ERS 1 and 2. So we definitely provide support for those sensors, and when I say support, I mean to the extent possible, the full support from all the different data formats and the beam modes and all those configurations. Just to qualify that a little bit more, we do support single, dual, Quad-Pol data, so fully polarimetric data. We have methods for doing automatic calibration and geocoding where the ephemeris information allows. We have lots of capability for reducing noise or doing what's known as speckle filtering. Very good tools for statistical and analysis capabilities. And really the strength of our system is you can go from a raw satellite image or an SLC single look complex image all the way to producing an orthorectified product and work maybe in a mapping application like ArcMap or ArcGIS to do your final mapping. There's no need to use things like GIMP or third-party software products to view the data or manipulate the data to transfer channels in and out, and integrate all the various information that can be generated as you process imagery. The Geomatica system has a very strong infrastructure for handling imagery. It's meant to handle imagery, and so that's really the benefit that you get in terms of working with Geomatica and when you're handling SAR imagery, along with any other type of imagery. So just a few quick words on us, PCI Geomatics. We have been developing remote sensing software for over 30 years. In 2012, we celebrated our 30th anniversary, so we're into our 32nd year, soon to be 33rd. We have a very popular desktop product, as you know, which we're going to be showing here, Geomatica. And it's composed of several tools. We have Focus, which is our viewing and analysis environment. Here we see an optical image, a high-resolution optical image. We have our Ortho Engine tool, which is a tool that's used for photogrammetry and mosaicing. We have a modeling environment, which is a nice way to visually create workflows and test out different workflows to see if we attain the results that we want. Also, we can achieve some nice automation here. In the same vein, in terms of automation, we have added with the latest version of our software the ability to script using Python in addition to Easy. Easy is our own scripting language that has been available with PCI software for many, many years. And Python has been added, and we think this is really going to help people who want to integrate other types of workflow elements together with the Geomatica software. Easy, as I mentioned, is our own scripting environment, and we have our 3D fly-through software. And Geomatica, in terms of SAR capability, has a number of algorithms, and one specific tool that was developed for analyzing radar imagery, specifically polarimetric SAR imagery, is known as the SAR Polarimetric Target Analysis, or SPTA. And you see it here on our toolbar. If you download the trial version of Geomatica, you'll get this button that looks like a radar satellite. And essentially what it does is it launches this software, which I'll be giving a live demonstration on. And we can do things like analyze specific targets, coherent and incoherent targets, map, generate response plots, look at different polarimetric measurements, and use that to really understand the backscattered elements back to the sensor. So we have, as I mentioned, a really complete remote sensing package. It's composed of 6 main applications. We've been innovating and continuing to add to our body of knowledge for over 30 years, and release the software very frequently. We have over 550 algorithms, and we just think this is a nice choice in terms of working with SAR imagery. It's a complete package for your use. So I want to walk through a couple of examples now on image analysis or radar-specific analysis that can be done primarily with polarimetric data. I will give a few examples on single-channel data as well. But this particular one is on agricultural monitoring. And the real strength of using polarimetric data and SAR data in general for agricultural monitoring is that contrary to an optical satellite system where you're really dependent on the absence of clouds and the availability of the satellite to capture the image that is required at key moments in the crop phenology, so that essentially just means the different crop stages as the crop is going from initial emergence all the way to growth and then senescence and then cutting the crop back down. So these key stages in the crop growth where we want to assess the health are really dependent, our ability to analyze the health of the crop is really dependent on the timing of the acquisition. And so radar data really is quite well suited to this, because we can essentially program the satellite to collect an image and perform analysis and determine what action needs to be taken. The information that is collected in a polarimetric image can be manipulated in a number of ways. We're not restricted to optical satellites are restricted in terms of the resolution of the satellite and also the number of spectral bands and how wide or thin the spectral bands are. So that's how we collect information over a target and use it to derive land use line cover classification or understand what's on the ground. The radar satellite, in particular with polarimetric polarimetric data, can provide a number of polarimetric parameters. So, and also a number of different ways of analyzing what we're seeing on the ground. So if we have an image that has 4 channels of data, so HH, HV, VH, and VV, we can perform a number of different measures. So for example, we could look at the change in intensity if we had more than one image across all of those channels, or any number of combinations of those channels. We could look at the change in the phase, or this is the time element of the signal. So if there's anything on the ground that has caused a change on the ground, it will be reflected in the phase or the coherence. So if there's any moisture that's appeared that wasn't there before, or if there's any change in the crop stage, that's going to affect the time element or the phase element of the signal. We can also look at the Wishart statistics. This is essentially a way to do a similar approach to a maximum likelihood classification. So we can compare multiple dates using Wishart statistics. This particular approach of classifying polarimetric data is suited to SAR imagery because of its non-Gaussian distribution or less Gaussian distribution as compared to optical data. We can look at alpha angle. So alpha angle helps us determine the orientation of the target with respect to the sensor. And then we can also look at entropy. Entropy is essentially a measure of dominant scattering mechanism. So if we have a low entropy value, what we can say is that there is a more likely a single scattering mechanism that is prevalent in that particular resolution cell, whereas if we have a higher entropy value, we have more than one dominant scattering. So we can say something about whether it's a bright double bounce composed of buildings, or maybe it's more of a volume scattering effect over a forested area or something like that. So using all of these different mathematical manipulations of the polarimetric data, we can really build a strong picture of what radar response we're getting, and we can use that in classification approaches, which I will be demonstrating. Here's a sample workflow of how we would do that. So as I mentioned, we would take a Quad-Pol image, perform some filtering to remove speckle or reduce the effects of speckle. Then we could compute the total power and do a change detection on the intensity, which is one of the 5 measures that I discussed. We could calculate polarimetric discriminators and use those. We could look at the change in phase, and we could look at the Wishart statistics across the different images. And using all of these parameters, we can build a more complete picture of what's happening with the crops and understand what changes are occurring and so on. Here's just a few examples. So this is a Wishart classification that's been applied to the same location across 2 dates. So here we see changes in the 90th percentile. So we can see the areas that have changed, that have a high degree of change. We can look at the straight intensity, just looking at the intensity of the signal and how that has changed over time. And again, we're working with complex imagery that is calibrated. We have the ability to calibrate the data, so we want to isolate the changes that have occurred on the ground as opposed to any of processing steps that have been applied. We can also look at the phase change, as I mentioned, the time element of the signal, and anything that would have perturbed the signal on the ground can be measured through coherent phase change detection. We can look at the alpha angle change. So this is the orientation of the features with respect to the sensor's line of sight. So if we have crops growing in a particular direction as compared to the sensor's illumination pattern, then we will pick those up. And we can also look at entropy. So this is a dominant versus multiple scattering mechanisms is what we're seeing here. So if we put all of these together, we can make a change map that takes all of these parameters into account and really build a better picture of what's happening at the precise moment that we need to collect this information. Again, no one system is completely independent of any other. I'm not saying that optical imagery wouldn't support this. What I'm saying is that radar data can really be helpful in terms of collecting the imagery at the right moment in time so that we can build an accurate picture of what's happening with the crops on the ground. Just a few other examples. So here I have an example of ship detection. So once again, we can use Geomatica to perform analysis on ships, so open ocean images, and trying to identify the specific location of ships. So we can leverage the fact that we have polarimetric information once again, and all of these tools at our disposal to address some of the typical challenges. So in terms of the target, some of the challenges are maybe the size of the target, the reflectivity or the type of material, the orientation and the velocity of that target. Other considerations include wavelength, polarization, resolution, and instance angle. With radar data, there are processing artifacts that are present, so we get the pulses repeating if they're very bright in both range and azimuth, and that can produce false targets or range and azimuth ambiguities. So we need to handle those. And also just noisy data due to meteorological conditions. So sea state that's very high, creating high disturbance on the water can create some problems. So these are all challenges that can be dealt with through the processing of the data in Geomatica. So once again, we can take our image acquisition, our initial image acquisition. We can run it through some decompositions. We can look at some polarimetric discriminators to identify the particular ships within an image. So just a quick example here. This is an original image that was just in its raw state, and obviously we have some issues here. We have some. It looks like we have some ambiguities that are present here. Some ships are repeating. We also have some high sea state. There's just some general disturbance over the water, which could be falsely detected as a ship if we have a very bright wave or a very bright location within our image. But if we perform polarimetric analysis on this data set, we can eliminate a lot of these false targets and arrive at a much better result. So here we have the detected image with the ships identified and some of the ones that were rejected as a result of them being artifacts or a result of sea state or something that isn't really a ship that could be eliminated. We can also get polarimetric information on the structure of the ship. Here we have a zoomed-in cargo ship with that's quite big. I believe this is over 150 meters long, and we can perform a simple decomposition. I think in this case it's a Freeman-Durden decomposition with 3 classes. So we have odd number, even number, and diffuse scattering, and that can tell us something about the type of ship that we're looking at. Again, the polarimetric information gives us much more information than just the presence of the ship. It can give us information about what's on the ship, or at least we can infer more information. We can't directly tell what's on the ship, but we can infer a lot more based on its structure and its polarimetric response. Classic example is using synthetic aperture radar data for flood detection. So here we have a workflow where we're pulling in a non-flooded image on the left. So this is typically an image that's stored in the archives over the location that we're studying. We pull in a current day flood. Again, we're working with calibrated data so that we're properly measuring changes. Those 2 images can be co-registered, and we can perform a specific change detection algorithm known as CCD-in10, which is adapted to radar imagery and will essentially provide us a change map, and then we can classify that change map and look for changes within the 90th percentile, so the most significant changes, and derive automatic flood polygons. And here I just have an example of the dry image, which is up here on the screen right now. Then we have a acquisition during the peak flood location. This is in just south of Manitoba, as I was mentioning earlier. And then based on that, after we run the CCD-in10 algorithm, you can see the areas in magenta are the ranked change, the percentile ranked change, which we can then classify and pull out a specific map of the location of the flooding. And this is, by the way, a demonstration that we gave in our webinar, and it's from 2009. And as it turns out, the Canadian government used RadarSat imagery for their assessment of the flooding on an operational basis, and you can see that the map that they generate and use for dissemination at the time is very, very closely correlated to the results that we generated using Geomatica. In fact, they were using not only RadarSat data, but most likely they were using Geomatica as well for that analysis. Also, there is some capability within our software to do intersection analysis. This is maybe something that could be done in our GIS as well, or other GIS package, but here's just a quick example showing this town that is cut off, except for maybe this one access route to the east here, so we can perform that kind of analysis as well. We can look at oil spills. Here I just have an example of what an intensity image looks like in the VV channel. So we have three suspicious slicks, if you will, or dark targets on the ocean surface here. If we were just to look at the intensity data, it's really hard to tell what is oil and what is not, natural emulsion or maybe just plant oil that's occurring naturally on the ocean surface. But using Geomatica and polarimetric data, we can actually calculate a number of discriminators, polarimetric discriminators. In this case, we're showing entropy, and what we're seeing here is the higher values, or the red values, have a higher entropy value, and so the response that's coming back is multiple, and there's multiple scattering mechanisms that are happening over these two locations here, as opposed to the plant oil, which really has a single scattering. So if you think about, if you know what oil does to the ocean, is it tends to slow down the waves, or dampen the waves, and produce like a rough surface, and so as a result of this polarimetric analysis, we can infer a little bit more about that. These two areas are potentially where oil is actually sitting on the surface of the ocean. Here we have oil spill thickness. So again, using polarimetric discriminators and polarimetric information, we can not only get the extent of the oil, but we can say something about the thickness of the oil inside the extent area. And this is something that can be done using conformity coefficient algorithm that's available within our software. And it's a very useful way to derive information regarding oil spills. So that's enough talking from me. Jason's going to do a poll, and I'm going to get set up for a live demonstration here.
Excellent. Thank you, Kevin. And basically, our next poll, what we're looking to know here is what kind of SAR processing software are you currently using primarily right now? There are a number of options available to you there. There are a couple commercial options, and we do know that there are a number of freeware tools available as well. So we've got Geomatica on the list, NV SARscape, Pulsar Pro radar tools, and MapReady are the freely available versions that are out there. Fantastic. Thank you, everybody. I'll share quickly the results there. Full 2/3 of you out there are using Geomatica, which is great. That's what we like to hear. The other third is mostly on the commercial side as well, using SARscape. But then the freeware tools, Pulsar Pro radar tools, and MapReady do have a number of users using them as well. So what Kevin's going to show you here now is a reason, if you're not in the Geomatica boat, to perhaps switch to Geomatica, or if you are currently using Geomatica, we're going to show you some new tools and new techniques that you can use in the software to make your job easier than ever. Back to you, Kevin.
All right, thanks, Jason. Well, hopefully everyone can see my screen all right. I've gotten rid of PowerPoint, and we'll be showing some software now. So I've launched the Geomatica 2014 software, which gives me this toolbar. These are the tools that I mentioned earlier. So Focus, our viewer, Ortho Engine, Modeler, Easy, Fly, and our SAR processing target analysis tool. I just want to explain that there's a little bit, maybe there's some confusion sometimes about our software. So inside our software, so if I launch Focus here and I open up the algorithm librarian, this is where we store all of the 550 plus algorithms. So if I go under radar analysis, I have a number of algorithms that are available specific to airborne, polarimetric, speckle filtering, and radar analysis. So I can pull these down and I can open these up. These are all available in Focus, they're available in Easy, they're available in Modeler. You can execute them in any number of ways, also in Python, by the way. So we can perform analysis inside Focus or inside the other modules of our software. But we have this other tool which is part of our Radar Ortho suite, or our Radar suite, called the SAR Polarimetric Analysis software, SPTA. And this is a really nice tool for quick and easy displaying and understanding of the polarimetric information that is contained within our image. So what I'm going to do is pull up an image that I have over Flebelins. By the way, this data set that you're seeing, or a data set similar to this one, is available for download off MDA's website. So Jason, I'm not sure if you have the URL, but you can probably push it out to the audience as I'm talking here. So what I'm seeing here is a representation of the data. So I have channels 1, 2, and 4 displayed in the RGB, but I have all of the information available. I have 4 channels, so HH, HV, VH, and VV available, and the software this software allows me to calculate statistics dynamically as I'm displaying the data set. So if I pull down the numerical output, I can change a number of things and get instant feedback here. So what I'll do is I'll draw a rectangle, and we have a tool called the Target Manager that's part of this. So we can start to, if you're familiar with supervised classification, you'll start to see kind of what I'm doing here. What I'm trying to do is I'm trying to build a library of classes. So if I draw a rectangle over this area, I can select, for example, the entropy values. I'll just clear that out and recompute it. And so what you can see here is I can get some real-time feedback over this particular location, and I'm getting an entropy value, the alpha angle, eigenvalues. These are all detailed information that I can collect on a particular target over this area here. So I can look at the pedestal height. I can do that as well. And I can do, if I wanted to just do a really quick classification or get an understanding of what this is, we can always use the Freeman-Durden, which is it gives us 3 simplified cases. So this is primarily, the response is primarily a rough surface. So this is not a double bounce, this is not a volume, it's primarily a rough surface. So that's what we're getting here. So we can do this interactively. We also have the ability to plot the results. So I can choose to plot the results in copolarized, and I'll apply linear scaling, and now what's going to happen is I'm going to get a response plot for that particular location on the image. And so I'm not going to spend a whole bunch of time explaining these, but essentially what this is giving us is the overall strength of the signal, so how much backscattered energy is coming back, and you could see that it's very, very low because it's water essentially, and the predominant scattering is displayed on the edges here, which is telling me that most of the backscattered energy is actually coming back from the vertical channels, the VV. If I had a peak in the middle, that would tell me that there's more scattering happening in the horizontal send, horizontal receive. So once again, very nice way to get a sense of the targets that I'm working with here. So if I'm building a supervised classification, which is actually what I'm trying to do here, I can go in and call this one water. So that's one target. I'll move over to an area here where I have some forest. So I can pick either a rectangle or I can draw a polygon. So I'll just draw an irregular polygon and try to get all of this location here, this forest. I'll go back to my numerical output and just show you some of the same things I was showing you earlier. So if I click on the Freeman-Durden, you can see here that the predominant scattering is actually volume scattering. And this makes complete sense because this is a forested area, so we have a lot of volume scattering occurring. The radar energy, some of it's coming back to the sensor, some of it's bouncing away. Essentially, we've got a sort of a mixed scatterer in this case. I can also look at the entropy values, so I'll just clear that out and look at the entropy. And the entropy values are very close to 1, so that this once again, maybe I didn't cover this earlier, but the entropy, if it's close to 0, essentially you've got a single or a dominant scattering mechanism that is backscattered back. Whereas if you have a value closer to 1, you've got multiple scattering mechanisms that are contributing to the backscattered energy. So here, again, we have an indication that this is a volume scattering, that there's multiple scattering mechanisms happening. So just a good way to understand what's there on the ground. So this one I can call forest. And I can move along here. So let's say this looks to be like an urban area, so I'm going to select a polygon here over this area. I'm going to go to my numerical output. I'm going to clear this out, and I'll start with the Freeman-Durden, which is nice and simple and easy to understand. So here we have double bounce as the predominant power contribution. So that makes total sense. That's definitely an urban area. We probably have some very linear features that are aligned in a regular pattern, and so the radar energy is hitting inside and in between the buildings and giving us multiple bounce backs to the sensor. So that's consistent with what we thought, and we can look at the other polarimetric discriminators. In this case, the entropy value. So here we have an entropy value that's closer to 0. This is a logarithmic scale, so 0.5 is not actually halfway between 0 and 1. It's a lot lower than that. So in this case, we have a dominant scattering mechanism, which would be most likely the double bounce, which is what we're getting. So that helps us understand what we're seeing. So here we will call this, we can call this urban. And we can move our way through. So if we select a new area, here we'll select an agricultural field, and I'm not sure. This looks to be like it's got some vegetation on it. And so if we look at this this particular target, and we'll go back to our numerical output once again, we'll clear that out. We'll do our calculations. So we have a very high entropy value, which once again gives us an indication that there's multiple contributions to the backscatter. We'll do our Freeman-Durden. So there we go. Volume scattering is predominant, and so that is definitely agriculture. So we can call this some growth. There's some growth in these fields. They're not bare because they wouldn't have volume scattering if they were bare, or they would have less volume scattering. If we look at one of these fields, this looks to be like an agricultural field that's got probably nothing growing on it at the moment. So if I look at the numerical output from that, I'll just clear that out for a second. I'll look at the Freeman-Durden, and what I have here is essentially the dominant scattering is not volume. It's more of a rough surface, or essentially it's a very smooth area. So that's what we're getting here. Is we have this is probably agriculture, and I'm going to call this bare soil or bare field. And we have some other natural areas that we can go and get. So here we have a wetland area. So we can maybe create a few locations here and look at those. So I'm going to call this wetland. And quickly do some numerical output here. I'll once again do my Freeman-Durden. So I'm getting predominantly double bounds, which is kind of interesting. There's probably some vegetation maybe that's standing in water, which tends to create a very, very bright response in radar, similar to what happens in urban areas. So that's consistent with maybe some reeds or those types of vegetation that are in the water. If I do my other calculations, my other polarimetric discriminators, I have entropy value that's 0.6. I would say that that's getting close to multiple scattering mechanisms, so consistent again with similar to an urban area where you've got multiple scattering mechanisms. So you can get a sense of how easy it is to sort of move around, select an area, perform any number of these calculations on the fly, get real-time feedback. In this case, what I'm using it for is to actually build training classes or for my supervised training, which I'm going to be running in a second here. But you could do quite a few different manipulations. You can look at the comparisons between different channels, so I can look at the phase difference between HH and VV in this case. So for example, if I do phase difference over HH and VV over water, I should get something pretty different. You know, there's really a lot of different analysis that can be done here, and it's quite a useful tool. So once we've done that, I'm not going to save any of this. I ran this previously. What I'll do now is I'll switch over to Focus, where I can pull up my project. So I'm just going to navigate to the location where my file is. Hang on, I've got a shortcut here. Make sure I get this right. And what I'm working with here is, once again, it's a complex SAR image that's a SLC format that's been brought into Geomatica and filtered using a boxcar filter so that we can reduce some of the speckle. So that's all that's been done to this image at this point. We've brought it into Geomatica. We've done some filtering on it. So you can see here we have the data set. And what I can do is I can pull up my training sites. So here I have my training sites, and if I just expand those, so these were created in the SPTA tool interactively, as I was showing earlier. And so I have multiple classes that I've created. I've got some open water, some urban area that's that's giving some double bounce that's within the line of sight. So it's essentially the alignment of the buildings is within the line of sight of the direction of the SAR sensor. If you zoom out here, the radar sensor in this case, I believe, was traveling from the north to south in a descending orbit and imaging out to the right. And so there are some differences in how some of the urban features look because of their orientation with respect to the sensor. You can see that these features are showing up differently than some other features that are not aligned with the illumination angle. So we need to actually pick out some of those differences and help our classifier along here. I'm just going to load a Landsat image so you can see what I'm talking about here. So if I zoom back into this location, this is all urban area. It's just that the street patterns are a little bit different, and radar is very sensitive to that because it's an active sensor and it illuminates the target. So if I just toggle between the SAR image and the Landsat image, you can see some of those effects. So essentially from here, what we can do is we can pull up the algorithm librarian, and we can run a Wishart supervised classification algorithm. So what I'll do is I'll open this tool up, and using this tool, I will specify the input channels to be used for the analysis, and I will also use the training classes. So the first thing I'll do is I'll select all of the channels that are available to me. So there are multiple channels. There are 4 channels in the real and the imaginary or the complex data format that are available. And then in my bitmap, So these are my training classes. I can select all of these and use them for the classification. And what I'll do is I will produce a file on disk with this classification result. So I ran this earlier, but I'll just run a new copy here. And you can see, hopefully you're getting a sense that I never have to leave the system. I can run everything inside Geomatica. There's no need for me to transfer things back and forth between different software packages. It's really an integrated system, and all the tools are there to make this all possible and make it easier to work with. There are some other tools out there where it's maybe a little bit more challenging to do this because there's so many steps involved in preparing the data and transferring the data around, and whereas hopefully what you're getting a sense of with Geomatica is it's a lot more straightforward to work with this. So I'm going to close this out. That only took a few seconds to run here, and I'm going to open that classification result. And what I'll do actually is I'll just quickly launch a project that I had running earlier, which has the classification result in addition to an unsupervised classification, which I ran on the Landsat image, which is going to be helpful here. So what we have here is our classification result from the Wishart classification. So essentially, what's been done is the phase change information that's contained in the data, in addition to the intensity values from those target sites, have been analyzed through the Wishart classification, and the software has tried to fit every single pixel, has run a test for every single pixel within the image, very similar to maximum likelihood classification, where the test was executed to determine class ownership depending on its similarity to the training sites. So again, if you're familiar with image classification, essentially the same thing happened here. The only difference is we use this Wishart specific tool because it doesn't assume a Gaussian distribution of the data. It's a bit better suited for radar data, which tends to have some non-Gaussian distribution, so it's better adapted to SAR imagery. So what we see here is the result of our classification. If I sort of zoom around, you can see our water here. There's a little bit of misclassification here in the water. But one of the things that really jumps out at me is if we compare this classification to a simple supervised classification of the Landsat image. So if I pull up my Landsat image here, I've got a false color composite. And one of the classic problems with optical imagery is the separation of things like bare fields with urban areas. You can see that spectrally there really isn't much difference between sort of these urban areas, these bright sort of white surfaces that could be roads or tops of buildings and bare soil. And if I turn on the ISO data classification over that particular location, you can see this particular field here, which has some bare soil, very closely, it actually gets misclassified alongside urban area. And we can actually eliminate that using the polarimetric information. So here we have our urban areas which are classified correctly, and if I turn that off, this one particular field here, which was getting picked up as urban in the unsupervised classification, is picked up properly as agriculture. So it's not a perfect system, but there are some specific capability and uniqueness to the radar data that allows us to leverage those polarimetric data to do a better job and complement what analysis could be done with optical imagery. So using both the optical imagery together with the radar imagery, if we have them both, this image, as it turns out, was collected very close in time to the Flevoland image within a few I believe within a few days or within a few weeks anyway. So we have similar conditions on the ground, and if we can get a situation where we get both sensors at the same time, that's ideal. But you know, every system has its own advantages, and hopefully you get a sense of how that all works. And I just want to spend a few moments now, and I won't go through all these in detail, but suffice it to say that with Geomatica 2014, we have added a number of new capabilities specific to radar. We've got new extended complex data support, and there's all of this information is available on our website. But essentially, we continually add new capability to our software suite. There are a number of improvements to metadata, which is used quite a bit for things like polarimetric analysis, so radar band, beam mode, pulse repetition, these kinds of things. We have some new SAR decompositions. There's a list of them coming up in the next slide. So quite a number of new polarimetric algorithms that are available within the 2014 version. So for those of you who maybe were asking for these, hopefully you see some of the ones that you've been asking for that are on the list now. And I encourage you to have a look at that. So Jason, I'm going to pass back to you for the final poll.
Excellent. Thanks, Kevin. Yeah, I do have one more poll here, and I just want to mention that along with the recording that'll be sent out tomorrow, we are going to be including the slides, so no need to memorize the list of new algorithms that Kevin just showed on the screen there. We will be distributing that shortly. So sort of a follow-up to the last question I asked. We asked last time whether you're using a commercial software of ours, competitors, or free software. What is the most important tool? What's the most important thing to you when choosing a SAR software tool? Cost might be the number one consideration. Perhaps it's speed, ease of use, or accuracy. And of course, it'd be great to have all four of those things at once, but usually that's not really the way it works. But we try to do our best here for sure. Perfect. Thanks, everyone. Ease of use won this round, which is interesting. Accuracy always important for sure. I do want to just mention a couple of things before we get to the Q&A. And if you have any questions, speak now or forever hold your peace. We did have a couple come in that I will get to shortly. But I just wanted to mention that in your chat window, you may have seen it flash a couple of times. And if you didn't, check there now. I did send out a number of links. The link that Kevin mentioned to the freely available sample data set, the data set from RadarSat, is on there, and I also sent out the links to the webinars we did over the past couple of months. One question here, Kevin, I see it's about basically the packaging of the software, and I'm not sure if you want to pull up a web page or not, but the question is how does one get the kind of tools that you were using in today's webinar? I know we have a software suite that includes a number of these tools, and some of them are available as individual add-ons, but I think you can probably explain it more eloquently than I can.
Sure. So it's pretty simple. I mean, we have different modules available within our software, starting the absolute base product that we make available is known as Geomatica Core, and what that does is it allows you to essentially view imagery, manipulate, do contrast enhancement, histograms, load support for all the different data. A lot of the automation capability is not available within Core. You have to move up to Prime. Once you move up to Prime, you have access to the scripting environment and the modeling environment. And then we have separate module for radar. So for radar specific processing, there is a separate module that needs to be purchased, and that gives you access to, if you want to orthorectify radar data, you can orthorectify the radar data. If you want to perform this polarimetric analysis, you can do that. So really it comes down to what's most important for your needs, and we can break it down for someone who's interested. You know, we have a conversation, and we can provide pricing information specific for a package that will work best for their needs.
Excellent. And something something that gets brought up from time to time is something we do have available. A question about the training options, and you can fill in any blanks I miss here, Kevin. But yes, we do have training available. The easiest way is on our website, PCIGeomatics.com/resources/training, and what we provide through that is we do an online training session usually once a month, and it's about a different topic on Geomatica every month. Unfortunately, we did just have our SAR course a week or two ago. It will be coming up again, probably not before the end of the calendar year, but feel free to check the calendar on that. We will also schedule a private training session for you if you like, and you can feel free to contact us about that. A really good resource that you can find on our website under resources and training is the textbook, the very same textbook that our instructors use during the training session is available free for download. So if you're so inclined, you can read the course book before deciding on whether to take the training. The training is a fairly intensive 2-day course, or perhaps try to teach yourself along the way. We do have a number of resources on learning SAR data, and yes, training is definitely one of them. I'll move on. Kevin is showing the trainings page there. A question about so this. Basically, the question is, after the polarimetric analysis and classification has been obtained, can you take this result and orthorectify it, or when does orthorectification come into this, if at all, during these processes, Kevin?
Yeah, so the answer is absolutely. It can be orthorectified. I will probably defer to someone like Gabriel, who's the guy who teaches our radar course. I believe that orthorectifying after the fact is better, just in terms of the workflow, but I don't think there's any difference. You can orthorectify before or after. It's really just a question of how you want to organize yourself in terms of processing the data. So if you orthorectify before, it might mean that you need to replicate a bunch of files and work with 2 separate sets of data, like unorthorectified, so you can keep everything in its complex data format to do the polarimetric analysis, and then you could transfer the results to a file that you could then orthorectify. It's really just a matter of preference in terms of how you work, but it can be done either at the front or at the back.
Perfect, thank you. And as I wait for any other questions to trickle in, I just want to mention to everybody, the last thing I like to mention is always visit getgeomatica.com. For those of you that aren't using Geomatica, this page is where you can get your 15-day fully functioning free trial that includes all the radar tools that were demonstrated today. It will also give you access via a big button at the top of that page. Will allow you to view any of our past webinars or see the schedule of our upcoming webinars. And another thing, lastly, if you've downloaded the trial and you like it and you're happy with it, on our website you can always check out the big Buy Now button, and that will get you in contact with the person, the sales representative in your area, wherever you happen to be in the world. It will connect you with our sales rep or authorized representative, no matter where you happen to be in the world. With that, I see no other questions have trickled in during my rambling there, so I will end this here. I want to thank Kevin for putting together the demonstration, and I want to thank each of you for taking the time to join us today, and we hope to chat again with you soon. Have a nice day, everyone.